Welcome to Hanselka's Math Lessons. I would like you to follow me along as I explain certain mathematics topics on my YouTube channel. My YouTube channel is Prof. Hanselka's Math Lessons. I encourage you to follow me along and be able to learn with me on YouTube. Please, you do have to subscribe on my channel, like the videos, as well as comment, so that I improve on areas you see lacking. Thank you so much. So today's lesson, we're going to look at travel graphs. Now, oftentimes, travel graphs is one of the topics that most students find so challenging. On the contrary, this topic is one of the simplest topics. Now, there are just areas that I will be able to explain to you, and I know for sure that you'll be able to appreciate, because I will be able to explain in such a way that everyone will be able to understand. So please follow carefully and attentively. Listen to my lessons. Let's get started. Travel graphs, we see that at times, the type of the graph that we're dealing with, we've got quite a number of types of graphs that at times we'll be able to deal with. For example, there's what we call speed time graph. There's a graph that will involve, that would be a speed time graph, or at times it can be a velocity time graph, or indeed at times it can be a distance time graph. Whatever it is, there are just a few concepts that you need to understand for you to be able to have confidence as you answer any question to do with that travel graphs. So one of the concepts that I want us to look at as follows, just a three. Acceleration. Acceleration, you must understand that acceleration is just the same as gradient. When we talk about acceleration, basically we're talking about the gradient. Okay? The steepness of a slope. And when we talk about speed, we're simply talking about velocity. Velocity and speed, these two units of measure are actually the same. And also when we talk about distance covered by something, that will be equal to actually the area under that particular region. Now, we have quite a number of graphs, like I earlier said. For example, you'll be able to have this type of a graph. You'll be able to have this type of a graph. This can be speed measured in meters per second. And this is the y-axis, having the speed in meters per second. And here, this horizontal axis represents time in seconds. So you may have this particular, for example, a ball is kicked. So you can even indicate can even indicate here that this is 0, then the highest speed is, roughly put, this is 50. Okay, so a cyclist starts his journey from here up to here for 4 seconds, after which he uniformly maintains this speed of 50 meters per second for the next 6 seconds, after which he turns back home. He turns back home. He turns back home at a time in the next 2 times. So this was the first, in the first 4 seconds, he maintained this constant speed of velocity of 50 meters per second. Remember, it was in the next 6 seconds, so it will be 6 plus 4, that is 10. Okay? Now here you are asked to say, number A, calculate the acceleration in the first 4 seconds. Then you can also be asked to calculate the distance covered in the first 10 seconds. And the last one, the question can be calculate the speed taken by the cyclist between 4th and 10th seconds of his journey. Okay, so how do you answer this question? These are beautiful questions. So calculate the acceleration in the first 4 seconds. So like I said, acceleration, there are quite a number of ways you can compute. From the concept I've given you about 3 concepts here. We said that acceleration is equal to gradient, just the same as a gradient. And it's easy for us to find acceleration and gradient For example, I want us to look at two ways. We're going to calculate acceleration using acceleration method or formula as well as gradient formula. You appreciate that to find the same, gradient. So here, let's talk about acceleration. So acceleration, I'll say method number one. So let's look at acceleration itself. So acceleration is given by final velocity minus initial over time. Acceleration is equal to final velocity is 15. Remember, the acceleration in the first 4 seconds. So here, if you look at the steepness of this line segment, this slope, you're able to see that, in the first 4 seconds, the final velocity was actually 50 meters per second. So put 50 here, minus the initial velocity, that's 0. Okay? Before he started, that's the initial velocity, and that was at 0. It was here, okay? So I'm going to write 0 here. And of course, everything divided by time. Remember, time has been given in the first 4 seconds. So put 4 here. And of course, we simplify this. 50 minus 0 is 15. Divided by 4. 2 into 50, that's 25. 2 into 4, that's 2. And of course, you have acceleration is equal to 12.5 meters per second squared. You can write this way, or you can say acceleration is 12.5 meters second to the negative 2. 12.5 meters second to the negative 2 exponent. This is one of the same thing. Now, let's use method 2 now. Method 2, we're going to use gradient. Now, gradient method, we know. Gradient, by definition, this is change in y coordinates over change in x coordinates. So this, we're going to say y2 minus y1, everything divided by x1 minus x2 rather, minus x1. So once we're done, we need to get into points along this slope here. So we can pick this point here and this particular point so that we calculate the gradient of this line here, this slope. So the point here at origin is 0, 0. So we're going to have 2 points. We're going to have the origin 0.0, and of course we're going to have 4,50. Okay, then we name these 2 points that we have. Of course, this will be x, this is y, this is x, this is y, but we name them. You can name these as 1, 1, then this as 2, 2. Then of course we substitute these 2 points into this particular, formula. So y2, that's going to be 50, minus y1, that's going to be 0, and of course x2, that's going to be 4, and of course x1, that's going to be 0. If you simplify this further, you see that 50 minus 0 is 15. 4 minus 0 is 4. If you simplify this, we're going to have 12.5 meters per second squared. And this is true. As we're able to see, what we're able to see here is that we have the same answer here. So we can now finally say, remember, we just use the gradient method to compute the acceleration. So here you can say, finally, you can say, therefore, the acceleration in the first 4 seconds taken by this cyclist is 12.5 meters per second squared. And this is the solution. So what you are appreciating here is that the answers are just the same. So meaning you can use any method here. Thank you so much, viewers. Please like the videos and subscribe to my channel. And don't forget to click on the notification bell so that each time I post a video, you are able to be notified. Thank you for your time. See you next time.